Good morning, students. Today we came to our online HVAC class day 18, right? So, today we will be dealing with E20 calculation. Okay, E20 calculation. Both we'll be doing it manually as well as we'll be looking onto the Excel sheet also. There is E20 form also. There is E20 form in which when we are giving all the input values, we'll be getting the output directly from that Excel sheet. Okay. So today you might be having to write a little bit more because that will be helpful for you also in this future. Okay. So today we'll be dealing with E20. E20 means estimation 20 calculation sheet. Okay. So mostly engineers will be using this estimation 20 calculation sheet for comparison also. So sometimes mostly we'll be doing our heat load calculation in HAP software, but for their verification, they will be using this E20 calculation sheet. So both HAP and E20 are almost similar, you know, almost similar in the sense, almost similar input values they'll be giving. Okay, so mostly they will be getting most accurate values for both the E20 as well as heat load calculation for HAP software. So, today, initially going forward with E20 sheet, we will be calculating E20 by manual method. So, when you are giving input values to E20 sheet, you will be knowing more about it. You will be having a good understanding about the values that you are giving. Okay. So, uh, while doing E20 calculation sheet, okay, manually, for one room, okay, it takes almost 10 to 12 pages. 10 to 12 pages. So in actual case, that is not practical, right? So we will be having n number of rooms for calculation. So that won't be practical when we are doing manually. So that's why we have E20 sheet. So automatically the answer. When you give values to the E20 sheet, okay, it will automatically, by the Excel, you'll be getting the values or the output. So here what we have to do is that we have to look different graphs and we have to calculate by the help of calculator. So that will help you also. Okay. So initially when you are studying this, you need to know, what are the different, steps involved in calculation of heat load. Okay. So that's why I am asking you to write it down. So it will be helpful also. So usually I used to take this E20 calculation by manual method for 2 days. Usually took 2 days. Okay, which means that it took 3.5 hours usually take. So now I'm not going for 2 days. I will try to complete within 1 day itself, which means that within 2 hours. So I won't ask you to just calculate it by the help of calculator. Some values I may ask you to calculate. Okay. So rest I will show my notes. Okay. Because usually you won't get any information regarding the manual calculations. You have to write it on notes. Okay? So that's why I'm showing you notes. But when it comes to E20 calculation sheet, I will give you the calculation sheet also. Okay, for your practice. I will show you also. Okay, how to calculate the heat load calculation by E20 sheet. That also I will be taking. Okay, so let's see whether we will be able to finish this today itself. So if possible, we could complete this E20 calculation by manual as well as by the Excel sheet today itself, or most probably by tomorrow. Okay. So I am giving the same question what I have given you yesterday regarding the O general. O general I have given you a lecture room or a classroom, right? The same question I am giving you right now also. So with that same question, we'll be able to solve the E20 calculation. Okay, my manual method. So I will share my notes, okay, right now. So the thing is that you need to copy it out. Okay, you have to copy it out. Then only you will be able to understand it. We'll be using different graphs, different tables. So, okay, so in order to find the values. Okay, so in E20 sheet, we'll be just giving the values itself automatically. The E20 sheet will be the E20 sheet produces the values. Okay, so I will share my screen. I will share my screen right now, so you can copy it out. Okay, so first you have to write the question. Okay, so this is the question. That is the same question that I have given you yesterday. So we can write today's date with the day 13, and we can write E20 calculation, load calculation by manual. By manual, it is shown here by manual. And you can write this question. Calculate the load that has to be applied to the structure below to maintain the room in human comfort condition. So this is our question. So here we have a lecture room and unconditioned space. For this room, this is the same question that I have given you yesterday, but we are going to find out the heat load calculation by E20 method, initially by manual. Okay, by manual method, we are going to find it out. Afterwards, when finishing this, I will take the E20 sheet also. Okay, so when we are finishing this manual method, E20 sheet will be very easy for you. Okay, so it will be very easy for you. Otherwise, it will be it will be difficult for you to understand that. So when we are doing this right now, it will be very helpful. So you have to write, okay, you have to draw this and you have to write one by one step. Okay, we'll be using different tabular columns and formulas. So uh, let me see whether I can show you the tabular column, or I'll be skipping and uh, you could write the values directly. Okay, so initially write the heading E20 calculation, load calculation by manual, and write this question. This is the question that we need to solve. This is the same question that we have done yesterday. Okay, so you can write this down and you can draw this. This is V1, W5, W4, W3, W2, W1 is the window, and D1 is the door. This is the size of the lecture room. This is the unconditioned space, which is 30 feet into 30 feet. This is also 30 feet to 30 feet. This is the orientation, north, south, west, east. Okay. Once you complete this much, just give a thumbs up. Okay. Have you completed this? So next thing what we need to know is that we need to know some various values, various parameters that we need to know. We need some input. Then only we'll be able to do the outputs. Okay, then only we'll be able to get the result. So what are the various input or data that we need for for the heat load calculation or for the result that we need to get? Okay, so note down the various data. Okay, note down the various data we need for the calculation. So in order to get the heat load or in order to get the capacity, we need all these values or all these various data that we need initially. So for example, if you are doing a project, we need to know its project details. We need to know where it is. We need to know where the location is. Because different countries, different locations, the climatic condition is different. So according to that, you know, uh, there will be a change. There will be a change in the output that we get. So first we need the project details, the location, all those things we need, the temperature conditions we need. The next, the outside design condition. We need to know the outside atmospheric temperature, dry bulb temperature, wet bulb temperature, humidity. Okay. We need to know the inside design condition. We need to know the what is the condition inside our room. Okay. Okay. Then we need to know the human comfort condition. We need to know how much temperature we have to bring it. Okay, to make a human comfort. Okay, that we need to know. Then we need to find out the infiltration and ventilation. So infiltration we have two different methods: crack method and ACH method. Ventilation we have three methods: by people, by area of space, and ACH method. These are the various data that we need for the calculation. Okay, so we'll be looking to all these five, input values. Okay, we'll be seeing it after writing this down. So you just write what are the various data that we need for our project calculation. Okay, then we can start from one by one. So write it down. Okay, when you are writing it, this is very important. Okay, that will be helpful for you also when you are doing hack also. Okay, so better you write it down. Okay, so today completely it will be notes. Okay. Once you finish, let me know. These are the 5 different data that we need, okay, for the calculation. I believe that rest of them also have finished. So initially we need all these values, okay, all these input values. Now for calculation of heat load, we need 7 steps to solve. We need 7 steps to solve, okay. So these are the steps involved in load calculation. So we'll be going by step 1, step 2, step 3, step 4, till step 7 is there. At the end of step 7, we'll be getting the capacity. So initially we were dealing with this 5 things, which means that project details or the data that we need for calculation, input values. These are the different steps that is involved for calculation. Okay, so solar gain through glasses, solar and trans gain through roof and walls. Yesterday we have dealt with ogen, right? Ogen. So we have seen the heat gain through glasses, windows, roof, ceiling, floor, etc. The same way. Every method is same. Okay, method same is similar. We need to know from where and all this heat is coming into our room. So we are using these different methods, okay, to finding that answer accurately. Okay. Yesterday we have done with O general sheet. Today we are going to deal with E20 sheet. Okay. But the motive behind all this is same. We need to know from where and all this heat is transmitting to our particular room. Okay. So yesterday, those who have came and those who have seen or done the origin or original heat load calculation, uh, this will be easy for them. Okay. So the steps that is involved in this is step 7, step 1 to 7. Okay, step 1 to 7. So you can write what are the steps that is involved in load calculation. Write these 7 steps, and we'll be going through these 7 steps today. And also the first 5 project input values also. The solar gain through glasses, solar and transmission or trans gain through roof and walls, trans gain except walls and roofs, infiltration and ventilation, internal heat generated, room latent heat, airflow rate. These are the 7 steps. Now, so these are the 7 steps. So initially we were dealing with these 6 steps. I told that we need all these 5 input values. Okay. So first we are going to deal with this topic. Okay. Then we will be coming to this 7 steps. Okay. So first, what is our first step? Or what is our first point? Project details. Okay. So here I am going to choose that my location is in Kochi. Okay. So yesterday we have seen, right, when we are dealing with origin. Okay, we have seen, I have chosen Kochi. We have seen a tabular column. Yesterday I have shown you, and in that you could see the wet bulb temperature, dry bulb temperature, humidity, all those things you have seen yesterday, right? I have shown you a tabular column. Okay, a graph, a sheet I have shown you. So the same sheet only. So here the project details is the, I have taken Kochi. I have assumed the location as Kochi. From that tabular column or from that sheet, you will be getting all the values like dry bulb temperature, wet bulb temperature, humidity ratio, okay, its latitude, everything you will be getting from there. Okay, from that sheet. So I am not showing you that sheet again. So first you write first point. You can write the solution. So these are the part of the question till step 7. Now we are going to solve each points. Okay, first we are going to deal with this point, project detail. So here I have chosen, assume the location of the project in Kochi from page number 5.21 in my textbook. So textbook won't be provided to you, but the sheets, the graphs will be provided to you. Tables will be given to you. But still, right, in my page number, it is page number 5.21. So you just write page 5.21 at summer. Dry bulb dB is 95 degree Fahrenheit and wet bulb is 82 degree Fahrenheit. So yesterday I have shown you that table. So you might be knowing it. Okay. So if you want, I will show you once more. Okay, I will show you once more. So you can see here, right? In summer condition, the state that I have chosen is in India. It is Kerala. Kerala, it is Kochi. So my location is Kochi. So I have taken Kochi. So I have taken Kochi. In that, all the values is being given. Latitude is given, altitude, daily range is given. Okay. Daily range, every values are given. Summer condition is given. So we are dealing with summer. So in summer, dry bulb, wet bulb, RH, daily range, altitude, okay, latitude, everything is given. So I have taken Kerala, in which Kochi, the latitude is 9.58, daily range is 10. My dry bulb is 95 degree Fahrenheit and wet bulb is 82 degree Fahrenheit. RH is 58. So these are the values that I will be getting from this tablet or from this table. Okay. So I am going to write that. So we can write it from page number 5.21 at summer. Dry bulb is 95, wet bulb is 82. Write this. So when we are doing this E20 sheet, it will mainly, as we are doing it in manual, we have to look different sheets or different tables. Okay. When we are looking HAP, when we are looking or when we are doing with HAP, just give the location. All these variable, wet bulb, latitude, everything will be generated by the HAP software itself. So we don't want to check all these graphs there. Software, just give the location, that's fine. We'll be getting all other values. Will be producing or generated by the HAP software itself. That is the advantage of that software. So here we have to look one by one by looking different sheets. But still it will be helpful for you. So you know more about how to take or, you know. So if you finish, just give a thumbs up. Okay. So what is our next point? What is our next point? First was project details. Next one is outside design condition. Same outside design condition from that same tabular column. Okay. From the same tabular column, what is outside design condition? Daily range is 10. Okay. RH is 58. Latitude is somewhat, 9.58. Okay. So we can write that also. So the outside design condition, latitude 9.58, daily range 10 degree Fahrenheit, summer design condition again 95 degree Fahrenheit, bed bulk 82 degree Fahrenheit, and RH 58 degree Fahrenheit. This is the second point. So you can write this value. Once you finish writing this, yeah. The next one is third point. Third point was inside design condition. So inside design condition, you have to look at table 4 of page number 5.13. That is not the tabel is not there with me right now. It is only in my textbook. So I will take a photo and I will just send it to you. But here, what it is said is that inside design condition, all these are input values. Okay, we have to look it from the tabular column. So inside design condition means first we have to take what is the application that we are using here. So here we have taken lecture classroom, right? So in that, recommended inside design condition, summer and winter. From that tabular column only we will be choosing this one, the third point. Okay. In that, a type of application is being given, like apartments, bank, okay, school, hotel, offices, like that. One column applications are given. In the second column, it's dry bulb temperature, relative humidity, okay, all those things are given. So write this third inside design condition. Okay, from table 4 of page number 5.13, we'll be getting you have to choose an application. Okay, here we are choosing school. Take school. Okay, take school because that is our application, because we have chosen lecture classroom, right? In that school application, the dry bulb and the wet bulb and the RH is being given. So we don't want wet bulb. Just write dry bulb is 78 degree Fahrenheit and RH is 50 degree. Sorry, 50 percentage. So write this. And in bracket you write takes cool. So I am not showing because these are not, we are not doing this practically. So that's why I am not showing all the, graphs. Okay. We are dealing with E20 sheet. Okay. So I am not making you to, do all those things because we are not doing it practically. But for your understanding only, just I am giving this. Okay. So inside the same condition, you just write dry bulb is 78 degree Fahrenheit and RH is 50. According to the application, this will change. So what is the application that we are choosing? According to that, inside the same condition changes. So here we have taken school as a commercial practice school, and we have taken the average value 78 degree Fahrenheit from table 4 of page number 5.13. What is our fourth point? Our fourth point is human comfort condition, right? So human comfort condition according to ASHRAE 55, it is said that the human comfort condition is 25 degrees Celsius plus or minus 2 degrees Celsius. That is the human comfort which is being recommended by ASHRAE. From ASHRAE 55, we will be getting the human comfort condition as 25 degrees Celsius plus or minus 2 degrees Celsius. So when we are designing something, we have to make sure that this temperature has to be set at 25 plus or minus 2 degrees Celsius. Okay. So which means that 75 degree Fahrenheit plus or minus 2 degree Fahrenheit. Okay. When you are changing to Fahrenheit, it will be the human comfort temperature is 75 degree Fahrenheit. Okay, or 25 degrees Celsius plus or minus 2. And the RH is 50 percentage. Okay, so you can write this also. And the other input value that we have is the conditions, outside and room temperature. So outside we know, we could get it from the graph or we could even get it from the psychometric chart also. All these values, we know the outside temperature is 95 degree Fahrenheit, wet bulb is 82 degree Fahrenheit, we already know, we have already found it, right? 95, 82, RH 58 and all. So you write all those conditions here. These are input values, okay? Outside 95, 82, 58, dew point temperature 78, humidity ratio 145. Okay? You'll be getting all these values. And our room temperature. What is our comfort temperature? 75 degree Fahrenheit. We have seen here. Okay. Wet bulb temperature 62 degree Fahrenheit. RH is 50. So if you know this dry bulb temperature and this RH, we could easily find wet bulb temperature, dew point temperature and humidity ratio by the help of psychometric chart. Okay. Or you can go directly to HAP and they will be giving all these values directly in that HAP software. So these are all input values. So just write it down this. And its difference is given here. 95 minus 75, 20, 82 minus 62, 20, 8, 23, 80. So these are input values, okay? So write it down this also. We are dealing with first 5 points, okay? These are the input values that we need to solve our question or solve our problem. If you get any two of these values, you could directly get all other values, okay, from the psychometric chart. In the first class or second class, I have taught you how to take different values. Once you complete this, just give a thumbs up. Have you finished this? All these are input values, okay? You could get it from the graph, okay? And by using psychometric chart also you can get it, or you could get the value from HAP also, okay? So we haven't seen or we haven't gone through the HAP. That's why I'm not taking the values from the. Okay? You could get all these values. You need to know any two values. Okay, then you will be getting all other values. Okay, so any two values we will be already knowing it. This we will be getting from the graph. Okay, 95 degree and 82 degree. From there you could get all these other values. Here we know the room temperature 75 degree Fahrenheit and comfort value is 50% RH. When you get these two values, go to the psychometric chart, find wet bulb temperature, dew point temperature, humidity ratio, and this is the difference of it. Fine. Okay. Now, what is our fifth point? We have completed the human comfort condition. What is our fifth point? Point is infiltration and ventilation. Infiltration, we have two methods. One is crack method and ACH method, right? So we'll be going to deal with that also. So that's how to do. Before that, before going to that, you need to write some given details also. We need to know the size of the window, size of the door, thickness of the wall, weight of the wall, thickness of the roof, weight of the roof. Okay, so write these details. If we know the thickness of the wall, we will be able to know the weight of the wall. Okay, if we know the thickness of the roof, we will be able to know the weight of the roof. So normally the weight of the wall will be 100 pounds per square feet, and weight of the roof will be 60 pounds per square feet. Okay, according to different thickness, you will be having different weight that you will be getting from a tabular column from page number 5.61. Okay, so I'm not showing it, just for your understanding. Just write this. So normally the weight of the wall will be 100 and the weight of the roof will be 60 pounds. So kindly write this given details. These are given details. Okay. So in our question you have seen we have a door, we have some windows. The windows dimension is given here. Okay. So write this down. The size of the window 5 into 5 feet, size of the door 7 into 5 feet, thickness of the wall 8 inch. From page number 5.61 with respect to 8 inch, we will be getting the weight of the wall as 100 pounds per square feet. Thickness of the roof is 6 and weight of the roof is 60 pounds. Okay. When you go through this once more, you will be thorough with this. Okay. Go to the video link which I will be sending you after the class. Once more, you just go through this, you will be thorough with this. So it will be very easy for you to calculate the heat load calculation by E20, Ogen, okay, HAB software, everything will be, you'll be having an idea about how to do that. Okay, so it will be more easy. So I recommend you to write this down. Sorry, like if you have finished, let me know, because we are dealing with one room only. So for completion of this one room, we need, I think there are 10 to 12 pages to complete. So, why I am recommending you to write this down, because when you do other, when you are dealing with this utility sheet and app software, it will be very helpful for you to understand. Okay, so just kindly uh, write it fast. So we need to complete it. Okay, and I just want to complete today itself. I am thinking to complete this topic today itself. Okay, so anyway, if you are finished, just give me a thumbs up. Now, there is a one factor known as bypass factor. Okay, so bypass factor we have to use during our calculations. So what do you mean by bypass factor is that the air will be passing through the cooling coil, right? So when the air gets contact with the cooling coil only, what happens? Heat transfer will be happening. So some air won't touch with the cooling coil. Some air will be bypassed through some other way. Okay, we cannot say that all the air gets touched with the cooling coil. Some air will be flowing here and there. Okay, which doesn't comes in contact with the cooling coil. Okay, so that air is known as bypass air. Okay, which doesn't comes in contact with the cooling coil. So in indoor unit there is cooling coil. In that cooling coil, okay, we will be having air will be passing through the cooling coil, and some air won't get touched with the cooling coil. Okay, so that air is known as bypass air. It is bypassing. It is not getting in contact with the cooling coil. Okay, so when we are calculating in further calculation, we need this bypass factor. So bypass factor means bypass air. The bypass air means the air which doesn't comes in contact with the cooling coil divided by the total air. Okay, that is the bypass factor. So write that bypass factor. Bypass factor is equal to bypass air by total air. Bypass air means the air leaving from air conditioner without in contact with cooling coil. Okay, bypass factor normally it is 0.1. That is an assumption. Okay, you will be taking 0.1 to 0.12. So normally we'll be taking 0.1 as its bypass factor. So wherever question they may ask what is the bypass factor, it can be 0.1. In each of the also they will be asking bypass factor. So you just give this value 0.1. So our fifth step is infiltration and ventilation, right? So in filtration we have two different steps. One is crack method, okay, and another one is ACH method. So just write the fifth point: infiltration and ventilation. So in infiltration and ventilation, this is the first point: crack method, right? Go to our project details. Fifth point in which there is infiltration and ventilation. In infiltration, we have two methods to find out the infiltration rate or infiltration. Okay. So you know that infiltration means the outside air will be coming to the inside room by some cracks or some window openings or something like that. Okay. So first one is crack method. So the formula for finding the infiltration through crack method is infiltration of air through window is perimeter of the window into infiltration rate. Okay. So what is our size of the window? We have already given details. In given details, the size of the window is 5 into 5 feet. So what will be the perimeter? Perimeter means the addition of all the sides or the four sides. So 5 plus 5 plus 5 plus 5 is 20 feet. So perimeter of the window is 20 feet. Multiply with infiltration rate, you will be getting the infiltration of air through window. So the perimeter of one window is 20 feet. So how many windows are there totally? How many windows are there totally? And find the total, perimeter of windows. How much will be the total perimeter? Perimeter perimeter of one window is 20. How many windows are there totally in our question? Yeah, we have 5 windows, right? So if it is 5 windows, what will be our total perimeter? 20 into 5, 100. Correct. So total perimeter is 100. So rest what so we got the perimeter of the window as 100. Right. So 20 into 5 is 100. That's what else we need. Infiltration rate. So infiltration rate for a window is 0.37. Okay. Infiltration rate of window is 0.37. That we'll be getting from page number 5.3 at other column is there. Infiltration rate for window is 0.37. Infiltration rate of door is 1. 0.37 CFO, okay, per feet of crack. And for non-residential doors is 1 CFM per feet square. Okay, that we can do it. Okay, so for here you just write perimeter is equal, for 5 windows is equal to 5 into 20, 100 feet. Infiltration rate for window is equal to 0.37. So you will be getting the infiltration of air through window is equal to 100 into 0.37 equal to 37 CFM. That is infiltration through window. So mainly the infiltration will be coming through the windows and doors, okay, openings. So 37 is our infiltration rate through window. So all these values you just note it down, okay. So we'll be doing the same question for E20 and we'll be applying this value. When we are doing E20 sheet, I'll be asking you what is these values, okay. So just note it down. So E20 sheet means these values will be putting it in an Excel sheet, that's all. Here we need to calculate 100 into 37 like that. So there automatically it is been by the Excel, the values is been or calculation is been done. So just give the value in that Excel sheet, you will be getting this 37 there. So don't forget, we are just dealing with one step, okay? First project details, then inside condition, outside condition, okay? Then infiltration and ventilation. So we keep in infiltration right now. So you just need to have a presence of mind, okay? What we are doing right now. So don't just write whatever is been showing in this, don't write blindly what you are writing, okay? So next one is infiltration of air through door. So the same formula, infiltration of air through door is equal to infiltration area equal to door area into infiltration rate. So area of the door is equal to, already we know that the area of the door is equal to 7 into 5 is equal to 35 feet square. It is already a given value. Now infiltration rate of for door equal to, from page number, same page number 5.63, you will be getting 1 CF. So infiltration rate of door is equal to 1 CF. Even if it is a non-residential door, okay. If it's a residential door, it is 0.5 CFM, okay. If it's a residential door, the infiltration rate of the door is 0.5 CFM. So find its answer. 35 into 1 equal to 35. Then you add all those values, 35 plus 37. So this is the infiltration rate through crack method. I think this is clear for you, right? So just add this both infiltration through crack method. Okay. Now infiltration through the second method is ACH method, right? Air change per hour method. Correct. First we were dealing with crack method. Next is ACH method. Household door infiltration is zero point 0.5 CFM. Household in the sense a residential door. Okay. It is zero point 0.5 CFM per feet square. So the next method is coming under infiltration is ACH method. So ACH method we need to know the, so just write the heading ACH. I believe that you have completed this. ACH method you have to draw a tabular column. This is important, okay? Uh, you can see the ACH 1.6, 0.3, 0.5, 0.30 air change per hour. Okay, so you may think, oh, only this much value, 1 or zero point 0.6 or zero point 0.3 or zero point 0.5 value only for ACH, because this is an infiltration. Okay, only very minute amount of air is coming inside. So that's why this ACH is very less. Okay, if it was ventilation, it could have 6, 8, 10 like that. The values of the ACH will be changing to that level. So we are dealing with infiltration, and you have to see different, estimation is given here. For example, neutral pressure. For example, if I am taking this room, if it is a neutral pressure, poor construction, the ACH is 1. So which means that more air will be infiltrated from outside. Now neutral pressure average construction, it is 0.6. Neutral pressure light construction, it is 0.3. Okay. It is not light, it is tight, okay? Tight construction. Now pressurized poor construction is 0.5, pressurized average construction is 0.3, pressurized tight construction is 0, which means that there is no air, it is tightly sealed, where no air will come inside or no infiltration will be coming into it, into a particular room. So this is important. ACH method, you draw this tabular column and write different ACH values. This will be already given the tabular column in the textbook, but still this is important. Okay, so write this estimation of infiltration of airflow. Is given in page 5.11. So this is infiltration. In infiltration, these are the ACH values. Okay, so don't forget. So in HAP also we need to give these values. So actually the ACH value depends upon the construction of the building. Okay, how the building is been constructed, by what material and how it is been constructed. It is neutral pressure or tight construction or average construction or poor construction. Depending upon that only this ACH value will be changed. So this is not light construction, it is tight construction. Okay, don't forget the third point. So here we will be using the same formula that we have used for ventilation. Okay, for finding the ventilation of air or Q value. We are using the same formula here. Once you finish this, let me know. So I believe you have completed, everyone have completed this. Yeah. So next is ACH method, right? So in ACH method, uh, you can write the value of the ACH depends upon the construction of the building that I have already said. So we will be using the same formula for ventilation. We have seen the formula volume in meter cube in ACH by 1.7, right? Or volume in feet cube in ACH by 60. We'll be using the same formula here also. The formula won't be changed. So infiltration air by the ACH method, this is the formula. And here we consider ACH value as 0.6. Okay. Here we have considered ACH as 0.6 depending upon this construction. Okay. So with that, with respect to 0.6, just find what is the infiltration CFM. So we are dealing with infiltration only. That's why we are taken ACH as 0.6. The formula is same. And we can take the height as 10 feet normal. Okay. The height of the building is 10 feet. And you know, width and the length of the building is, or the floor is 30 into 30, 300. Sorry, not 900. These are all very, very simple only. Any doubts you can ask me. So these are all simple things only. Just write it down. Okay. But how do we take construction type with respect to projects? Normally, you know, we'll be taking 0.6 only. You just choose neutral pressure average construction. Okay. If it is some steel material or something like that, you just take one. Or you need to ask, you know, we'll be knowing according to what to choose. Okay. Or you need to ask to the architect what type of construction that you are using. Okay. So if not given, you just take 0.6. How do we decide poor? Yeah. How do we decide means that we know now, right? Like if there is many windows and openings and all those things, we'll be taking it as average construction only. Okay. This is just to compare what type of building we are using. Okay. It won't make very much differences, but poor construction, average construction, light construction in the sense, you know, light construction in the sense how we are building it. How is there any chance of air to come from outside to inside through infiltration? That's what we are looking. In some, you know, in some rooms and all, it will be pressurized and tight construction. Okay, in some, you know, like recording studios and all those things, it will be very tight. So in that case, we'll be choosing ACH as 0 itself. Okay. So this, you got the infiltration rate or the infiltration of air. Mostly it will be an average construction only, so directly give 0.6. Okay. What is infiltration air? CFM. What is the answer? Yeah, it's 90 CFM. Correct. It's 90 CFM. So it's 90 CFM. Uh, so we were dealing with infiltration by crack method and ACH method. And comparing the crack method and ACH method, which is the largest value? Crack method or ACH value, you got the largest value or the highest value? You got it for ACH method, right? You got it for ACH method. So when you are when some in some places when they ask infiltration, you have to write the highest value. Okay. So now select the highest value of infiltration. It's not infiltration rate, infiltration air. Okay, it is infiltration air. Now you have to select the largest value. Select the largest value of infiltration. So the value is 90 CFM. Next, what is our fifth step? Next one, infiltration and ventilation, right? Ventilation means usually the outdoor air. So there are three subdivisions for ventilation, correct? What are the three subdivisions? By people, by area of space, and ACH method, correct? Let's go through the first 5 points of the given values that as we need for the calculation. In ventilation, we need three different steps, right? Three different subdivisions is given. By people, by area of space, and ACH method. So we are going with by people first. Initially, we are going with people. So ventilation by people. So ventilation by people, the formula is ventilation air equal to number of people into ventilation rate. So yesterday when we are dealing with, when we are looking the O general sheet, we have seen the number of people, right? We have gone through a tabular column. Different applications are there, according to that different numbers per 1000 square feet is given, right? And we have found the number of people in our lecture classroom was how much? Any idea? What was the number of people in the lecture classroom depending upon our area? Any idea what was the number of people? Yes, 59. 59 people was, yeah, there was 59 people. Okay, so the same thing. Ventilation by people, this is the formula. Number of people in lecture classroom is equal to 65 people per 1000 square feet. That we will be getting from that tabular column. So we have 900 square feet. Correct. We have 900 square feet for our lecture classroom, 30 to 30. So for 900 square feet, how much people will be there? 65 divided by 1000 into 900, 59 people. Correct. So we got number of people. Again, we want ventilation rate. So I will show you that graph, that will be better. So you could see lecture classroom, the number of people was 65, and people outdoor air rate, how much CFM per person? Just see 7.5. Okay, CFM per person 7.5, and CFM per feet square 0.06. So this value also we need for next calculation. Okay, so CFM per person is 7.5 for lecture classroom. CFM per feet square is 0.06 for lecture classroom. So Ventilation air or outdoor air, page number 5.57. Ventilation rate per person is equal to how much? 7.5 CFM per person, correct? 7.5 CFM per person. So don't forget all these values, okay? We need these values in future calculation also. So find out the ventilation air 59 into 7.5. What will be the answer? Just give a chat. What's the answer? Ventilation air by people. Or 42.5. Correct? Or 42.5 CFM. Correct. What is the next method? Next method in the sense ventilation by people, then ventilation by ventilation by space, right? Ventilation by space. Ventilation by space, ventilation are equal to floor area into ventilation rate. So floor area equal to we know 900 feet square and ventilation rate by space is equal to 0.06. The same tabular column. Area, ventilation by area. Okay. Lecture class out is 0.06. Okay. So multiply with 0.06, you'll be getting the value. The next method is ACH method. The same formula you can use, and you can choose ACH as 6 here because it is ventilation method and it is an ACH method. You can choose 6 as the value. I think this is clear for you, right? Any doubt, you can ask. Okay. Next one is ACH method. Here we are using from page number 5.7. We have 6. According to different applications, you could choose. Sorry. Sorry. Now we have already seen the first 6 or first 5 points given data. Okay. Now we are coming to the solution. So you can see step 1 till 7. We have seen step 1 till 7. You have to go through this first step 1 till step 7. Okay. So this is similar to that what we have did yesterday. In E20, sorry, in Origin, we have seen solar gain through glasses, solar gain through roof and wall, transgain means solar gain to accept walls and roofs, infiltration, ventilation, internal heat generator, room data and heat. So these all are similar. Okay, all these things are similar, and we have here also we have to go through all these 7 steps. Then only we'll be getting the heat load properly. Okay, so as we have studied the origin yesterday, this will be you'll be having an idea what you are doing right now. Okay, so these are the 7 steps. So first parameter is over. We have completed the first 5 points already. We have completed first 5 points, or the various data that we need that we have already completed right now. Now we are going to the steps that is involved in load calculation. This is the main topic that comes in solving our problem. Okay. So this is, as I said, this is very similar to the origin sheet also. Okay, which is not same, but which is similar. Okay, which is similar in the sense we are trying to get the heat which is transmitted from sunlight or walls or roofs or electrical equipments like that. We are going to find it out. So we have these 7 steps through which we are going to find out the heat which is transmitted into our room. Okay, so let's go. We can go with our first step. Okay, first step is solar gain through glasses. Okay, solar gain through glasses. So write the heading, load calculation step 1, solar gain through glasses, and this is the formula. Q is equal to UA delta T. Q is equal to UA delta T. This is the common formula that we will be using for every steps. Okay, every steps in the sense at least first to 5 steps. So in order to find the solar gain through glass, we need U factor. This is the U factor. This is the A means area, delta T means temperature difference. When you get these 3 values only, you will be getting the solar gain. So this is a very important formula, very important formula. Q is equal to UA delta T, in which Q is equal to heat gain. Okay. So coming back to the question. This is our question, right? And this is our orientation, correct? North, south, west, east. And we know that this is the partition wall. This is the partition wall. And we have exposures. We have exposures, direct exposures from the sunlight in the north direction, in the west direction, and east direction. Correct? In the east wall, north wall, and west wall. In the south side, there is no exposure because it's a partition wall. Okay, so keep this in your mind. This diagram in your mind, and this orientation also in your mind. Okay, so now we are going to deal with this. Now we know step 1 is solar gain through glasses. This is the formula, Q is equal to UA delta T. Q is the heat gain. Now we are going to deal with the north glass. Wherever there is exposure, that only we are considering. Okay, wherever there is exposure, that only we need to consider. We need to consider wherever there is exposure of sunlight. Now, A equal to, we need these values. We need U factor, we need area, we need delta T. All these 3 we need to find it out. Okay, so A means total area of the north window. Okay, because we are dealing with solar gain through glass. Okay, solar gain through glass. So we are finding it separately. Okay, we are finding it separately. So A equal to total area of the north window. So what is the area of the window? Length into breadth. Okay, so how many windows are there at the north side? There are 2 windows, right? There are 2 windows at the north side. So what will be the area of the window? 2 into 5 into 5 is 50 feet square. So one window it is 25 feet square, and another window it is 25 feet square. So there are 2 windows at the north side. So we have the area as 50 square feet. Understood? So we got area. Rest what else we need? We need U factor and we need delta T. Correct? So U factor means U factor is given as 0.56. As I was already said that this U factor should be given by the architect, or we have to find it out. So yesterday or last day we have seen how to find the U factor of the walls. Okay, and we have tabular columns. Okay, for different U value for different glasses. Understood what I am saying? So page number 5.32, in page number 5.32, there is a tabular column in which different glasses are given. And according to that, depending upon light color, medium color, dark color, its U factor is being given. Okay. So let me show you if there is. Okay, this is the overall factors of solar heat gain through glass. So you can see type of glass here. Okay, you can see type of glass here, and if there is no shade and shade is there. Okay, so here we are choosing if there is no shade, and you can see here light color, medium color, and dark color. Okay, so you can see here ordinary glass, regular plate, heat absorbing glass, double pane, triple pane, like that. Painted glass, stained glass, different types of glasses are given. So what is the glass that they are used on their walls? According to that, you have to take the U value. So these are the different U values. So here I am assuming it's an ordinary glass. Okay, it's a light color glass. You can choose whatever you want according to the application or according to the glass that really is being given. Okay, by the architect. So, or the client. So here the type of glass I am choosing is ordinary glass, and here I am using a light color. A light color. So the U factor is 0.56. Okay, for glass. So you can write 0.56 is the U value, overall heat transfer coefficient, U, from page number 5.3. Okay. So you got U value, you got A. Next you need to find delta T. Delta T means temperature difference. So to find out the temperature difference, you need to know you have to choose from a tabular column. Okay. So initially you know how to calculate the area, then you have found out how to find the U value by the graph or the tabular column. Now you are going to find the temperature difference. How to find the temperature difference? See, the delta T value is taken from page number 5.40 or 41. 5.41, okay? It is 5.41, depending upon the latitude value of the location. So normally our latitude value is 9.58 that we have seen in Kochi. So we can take it as approximately 10 degree. Okay. So delta T value is taken from page number 4.51 depending upon the latitude value of the location. It is taken as the highest value among the result from the hottest month between 8 AM to 4 PM. So here the highest value is 39 degree Fahrenheit. So we can see how they have taken. Okay, we are going to find the delta T value. Delta T value, let me see. Yeah, I don't know whether you can see or it is in a blur shape. So this is the thing, solar heat gain through ordinary glass. This is our latitude 10 degree. And you can see here different month: June, July, May, August, April, September, March, October to February, November to January, December. Yeah, so here mainly our hottest month will be July, May. I'm taking this, okay? For example, I am taking this July to May. Okay, July to May. So this is my latitude. Okay, this is my hottest month. Understood? So, which is my exposure? Which is my exposure? North or south or west or east? North, correct? North. So I am taking this 10 degree latitude. I am choosing this as my hottest month. So in your location, some days August might be the hottest month. So you can take this one. So here, for example, I am taking this one. And let me see the north exposure. North, northeast, east, southeast, south, southwest, west, northwest. Every orientation is given, in which I am taking north. In north, you can see here the time: AM, PM, 6 AM, 7 AM, 8 AM, 9 AM, 10 AM. It goes noon, then 1, 2, 3, 4. So we have to choose a highest value between 8 AM and 4 PM. Okay, between 8 AM and 4 PM, you have to choose an highest value. So you have to look the latitude, you have to look the hottest month, you have to look the time between 8 AM and 4 PM, and you have to look what is the highest value in the north exposure. Because initially we are dealing with north exposure, we have to see what is the highest value which comes between 8 AM and 4 PM. Let's see what is the highest value. 39, 35, 33, 31, 30, 31, 33, 35, 39. So what is the highest value between 8 am and 4 p.m. in the month of July and to May? The north orientation, this 39 degree Fahrenheit. Correct? This 39 degree Fahrenheit. So apply there 39 degree Fahrenheit. So you write how you got this 39 degree Fahrenheit. Okay. The delta T value is taken from page number 5.41. Depending upon the latitude value, you have to write this or you will be forgetting this. Okay. Otherwise, you have to look the recorded video again and again. So depending on the latitude value of location, it is taken as the highest value among the result from the hottest month between 8 am to 4 p.m. So here you got delta T as 39 degree Fahrenheit. So you got U value, you got A value, you got delta T value. Correct? Then you find VQ. Find Q value. You got all other values. You got U factor, you got area, you got delta T. Then you find Q, heat gain. And give me the answer in the chat box. So for all other orientation, you will be using the same step. How do we take latitude value of the location? The latitude value of the location is already given in the question. 9.58. That you will be getting from the tabular column, which I have shown you. Right? You have chosen Kochi as the location. So from the tabular column, you will be getting all these values. Wet bulb temperature, dry bulb temperature, latitude, everything will be given. RH. .84. What is it? 21.84. How you got 21.84? Just see, multiply this 0.56 with 39 with area 50 square feet. What is the value that you will be getting? Is it 20? Is it 21 point? Others also just find it out and show me. Is it 21.84? You'll be getting answer in BQ per hour. Okay. 21 is not correct. What about others? Dinas, Shepherd and all? Are you doing right now? What about Jacob? Are you writing? Or others you are just sitting there? .1092. Yeah. 1092 BTU per hour. That's correct. Okay, Jacob. Yes, correct. Jacob got correct answer. What about Kirti? Why did you get 21.84? Yeah, 1095. So you got 1090 BTU per hour. So what you have to do is similarly you find it for the heat gain values for other windows also. Other windows means other exposure. We have found it for north side. We have to find it for west side and east side. West side and east side. West and east. South side you don't want because there is no exposure. So east glass UA delta T, area you know. Delta T you have to, delta T will be different, okay? You'll be using the same step, but it will be different. For example, the same step, you can use the same step, but it is not from the north, it is from the east, and it next from the west. So from the east, what will be the value? From 8 a.m. to 4 p.m. 158, 142, 498, 43. 158 is the largest value. So delta T will be, for east wall will be 158. Correct? And for the west, let's see, for the west how much? 11, 13, 14, 14, 14, 19, 142, 158. So 158. You can take 158 for that also. And add all those values. First, every value will be same, okay? And area will be different according to the windows, number of windows there, and write down this thing. Similar method what we have done. We show the previous page for 1 minute. You want this previous page or the other tabular column? This one. You want this page? Okay. So complete this, and similarly you find out the heat gate values for other windows also. And delta T value for both is 158, and find out the answer. East glass window, west glass window, and find out the answer. Same method, okay? U value will be same, area will be different, and delta T will be different. Area you can find it out easily. Delta T will be 158 for both. Let me know your answers for east glass and west glass. You can use the same step. Yes, Kirti, you got the correct answer. It's fine. It's correct. This class is 4424 and best class is 2212 BQ per hour. What about others? Are you getting the same answer? Now what you have to do is that total heat gain through windows. Add all those values. 2212, 4424, 1092. And get the total value. Yes, 7728 BTU per hour is the total value. Let's see whether we are getting like this. Let's compare whether you are getting the answer from this. You are completed, just give me a thumbs up. Okay. Okay. So our first step is over. We got heat gain through windows or glass, right? What is our second step? Solar and trans gain through walls and roofs. So walls and roofs, right? So write the second step. Solar and trans gain through walls and roofs. So first we are going to deal with wall. Then we are going to see what about roofs. So initially we are going to deal with wall. The formula is same, okay? Wherever you use this formula is same. UA delta T. And in that you need U value, you need area, you need delta T. Okay? So the U value will be different and the delta T also will be different. Okay? Area you can calculate. Correct? So, right. Solar and transcrete through walls and roofs. First one we are dealing with wall. The formula is Q is equal to UA delta T, in which U is equal to 0.28 from page number 5.30. I will show that. So there is a tabular column. So this is for you. These are the different U values. Okay, these are the different U values corresponding to floor or ceiling, roof. Okay, these are different materials. According to that different materials, you can choose the U value from here also, from this tabular column. So here we are dealing with wall, right? Wall. So let's see. Yeah. Overall heat transfer coefficient U for building construction components. So wall. So here I have taken 0.28, right? 0.28. So I have taken this plugged gypsum wall board half-inch with no insulation. So you can choose whatever you want for wall, okay? And you can choose whatever you value according to the correct, real project. According to the real project, you can choose. Okay. And here just I have taken 0.28 as my U value because I have chosen this masonry 4-inch face brick, 4-inch common brick. Okay. In that inside finish is for the gypsum wall board. Okay. In that I have taken 0.28 as my U value. Okay. So according to different construction, different materials, you can choose from this tabular form. So I have chosen U value for wall as 0.28. So you write 0.28 from page number 5.30. According to different construction, the U value will be changing for walls also. Okay. So you got U value. You need area and you need delta T. So area you know, right? Area of the wall, which is the wall that you are using. You can calculate the area. Okay. Provided that you reduce the windows dimension. windows area. Okay. Now delta T, here we are choosing the delta T in a different method, different way. Here we are choosing delta T by how to find out delta T is ETD plus CF. ETD means equivalent temperature difference and CF means correction factor. We need to know these two. And when we are adding this equivalent temperature difference and correction factor, we will be getting delta T. Okay. So initially you write this. Then we can find out one answer. Write step 2, write walls and write its formula and write what its U value, how to find delta T. You write this initially. Write it down. Then we can do one. So now we are dealing with step 2, okay? Solar and transmitting through walls and roofs. So initially we are dealing with walls. After completing walls, we can deal with roofs. So the formula is same, 2 is equal to U delta T. U will be getting from the tabular column. A you can calculate it from the problem that you have given. Delta T also you will be able to get it from the table solution. Once you finish writing this, let me know. Okay. So for the time being, we can stop it here. Next day we can continue with this. Okay. So today we were dealing with E20 calculation, right? Estimation 20 calculation. So estimation 20 calculation in the sense we have dealt with manual calculation. Okay. So usually we need some input values. Okay. Then we have found it out. Then we have 7 steps to find out the heat load calculations. So today we have found gone through step 1 and we have started step 2. So step 1 was solar gain through glasses. So what we have did is wherever we have exposure, we are choosing that orientation, correct? From there, we have found out the solar gain through glasses. So the formula that was used was Q is equal to UA delta T, in which U is the overall heat transfer coefficient or U factor, and A is the area, and delta T is the temperature difference. For each step, delta T will be different, area will be different, and U also will be different. U means U for glass will be different from U for walls. U for walls will be different from U for U value for roof. U value for roof will be different from ceiling. Okay, and it depends upon that. So you need U value, you need area, you need delta T. So tomorrow we could start with step 2. So I thought to complete all these steps, 7 steps today itself. So we don't have much time. We didn't get time to complete all those things. So tomorrow we'll make sure that we'll be completing E20 till step 7 plus E20 sheet also. Okay, when you complete this manual method, it will be very easy for you to do the estimation on the sheet, E20 sheet, because we are just directly taking these values and putting it into the E20 sheet, and directly E20 sheet will be giving you the answer. So here we are doing, and we are calculating. We are choosing each tabular columns and all those things. There also we have to use tabular columns, but still we don't want to calculate it by the calculator. So automatically the Excel sheet will be producing the set. Okay. So I think there is we could wind up today. So is there any doubt? We have 2 minutes. Is there any doubt regarding today's topic? No, then we can wind it up. So just go through the link, video link that I am sending you. Okay. So thank you, students. Thank you so much.